Hi guys, this is Pat with 3D Wonders. At 3D Wonders, we help our customers find the right 3D scanners and software for their reverse engineering and inspection needs.
And to show you exactly how we approach real reverse engineering projects, our engineering team will walk you through a complete workflow from raw scan data to a finished 3D model. Let's get into it.
Hi, in today's video, we're going to walk through the reverse engineering workflow for a wheel hub using QuickSurface inside SolidWorks. This tutorial takes you from raw scan data to a clean, fully parametric CAD model. The scan for this project was captured using the Creality Raptor X, a hybrid 3D scanner with blue laser lines and NIR structured light, ideal for engineering parts like this wheel hub. Let's dive straight into the process. Before beginning the modeling steps, always check whether your scan data is already aligned to the coordinate system. If it isn't, make sure to perform alignment first to establish a reliable orientation for the entire workflow. The wheel hub's main structure is a revolved shape, so we start by defining a center line to guide the process. We then create a cross-section to capture the hub's primary silhouette. Using Extract Primitive, this cross-section is converted into a sketch to maintain an accurate relationship between the scan and the solid model. With the sketch ready, the revolve operation forms the main body. A 3D comparison helps us evaluate the deviation between the solid and the scan. One area shows a larger gap, so we add a fillet to bring the surface closer to the scan geometry. With the main body established, we begin building the first detailed feature. A cross-section is placed at the required position using the slicing plane, adjusted as needed for clarity. From this section, we sketch the feature profile. This body will be used as a subtraction tool, so its dimensions must follow the scan shape. The feature is created using a revolve set to mid-plane, with the rotation angle adjusted for the intended feature. This revolve will later be trimmed using the planes we generate. Planes on both sides are created using Extract Primitive, providing the trimming surfaces needed for cut with surface. Along the revolved edges, the scan shows a tapered radius, smaller at the bottom and wider at the top. So we apply a variable fillet. We then perform a circular pattern to repeat the feature around the hub. Once the feature is created, it is subtracted from the main body. Next, we move to the bolt holes. We start by identifying the center line of one hole. To do this accurately, we create a cylinder using a sketch, so its axis stays centered with the coordinate system. From this cylinder, we extract the center line as the hole axis. Using that axis, we create a cross-section and sketch the hole profile. We revolve the sketch, apply a circular pattern to duplicate the holes, and then subtract them from the main body. A comparison analysis confirms whether the deviation remains consistent. Now we move to the next detailed feature in the bottom area of the hub. Begin by selecting only the scan region related to this profile, making sure the selection stays within the intended boundary. Create a cross-section and position the slicing plane accordingly. Enable through selection only, so the cross-section is based solely on the selected mesh. Activating outline captures the entire boundary of the chosen scan area. Sketch the resulting profile. Then revolve it into a solid body. Use extract primitive to generate planes on both ends of the feature. These planes are then used to trim the body. A cutting surface is created to remove the central portion of the feature. Trim the body using this surface. Add fillets to smooth the edges. Apply a circular pattern to repeat the feature. Subtract the pattern geometry from the main body. Perform comparison analysis. Made fillet adjustments to bring the surface closer to the scan geometry. A final check confirms the updated deviation. This final profile follows the same method as the previous feature. What matters most here is keeping the sketch aligned with the cross-section so the resulting geometry stays true to the scan and maintains minimal deviation. And that completes the reverse engineering workflow for this wheel hub. We've taken raw scan data and rebuilt it into a precise, fully parametric CAD model inside SolidWorks using QuickSurface. This process demonstrates a reliable approach for recreating complex components with accuracy and engineering intent. To explore more workflows like this,
please visit our website 3dwonders.com. If you have any question or want to see a demo, send us a message and we'll get back to you.